All right, welcome, ladies and gentlemen, to week number 56 to Open Live Q&A. My name is Mr. McLogan, and I am happy and excited to have you again on for another live stream where I'm here to answer your questions as well as help you out with your math. But there's a couple of things I want to go over with you guys tonight, and that's one of the things kind of looking into, a couple things that I talked about in my community post as far as where you guys like to get with math. And then also for the title of this, as far as tutoring and Discord and how that kind of connects. So if this is your first time on one of my open live streams, I have questions that students submit to me each and every week that I go over and answer them at 9 p.m. every Sunday night. And then also people submit some questions that I'm not able to get to. And that's where a lot of these questions also get placed into the Discord. So welcome Daniela and Maggie and Abigail. I see you guys on. Thank you so much for joining in. And so I wanted to kind of talk about, some common themes that I've been coming across when I receive a lot of questions, because I get a ton of questions each and every week. And I really am thankful that you guys have reached out to me to, see what I can do to be able to answer your questions. And unfortunately, just with restrictions of time and mental capacity, I'm not able to get to each and everyone's questions. But besides people asking me, individual questions on what they, how to do this problem, how to do that problem, I think one of the other things that have come through doing my live streams for 56 weeks in a row now is a lot of students are always asking, like, how do I get better at math? Like, how can I get better? How can I get better? So one of the questions I asked on my YouTube channel this week is I said, hey, when you guys are struggling in math, how do you like to get help, right? Do you like to reach out to get help with a tutor? Do you like to, use apps like Photomath or Mathway that like shows you the answers? Do you prefer online video? Or I can't remember what else the other one was. I think there maybe was one more, or just like websites showing you the solutions and looking through the work. So I'm going to kind of go through, take a look at that, show you guys the results and kind of talk to you, as far as how you can not only get help, but also one thing, how you can improve upon your skills in mathematics. So I see have Jaden and King and Evan, and DNL and Julius, Aisha and Gabe. Thank you so much, guys, for joining in. Wish you very much, Gabe, on your exam. You got this. So one of the things I wanted to talk about is as far as the Discord server. So I started the Discord last year just as a way to give students a little bit of a, access to help each other out, with their questions, and also just to kind of submit their questions out kind of into the open and see who could be able to help them out. And I think it's really important that as you are learning math, that you don't feel alone, that you have somebody or people that you can reach out to and always get help. Because I remember when I was struggling with mathematics, it was, I needed always somebody that I could refer to or get help or ask, how to do a problem or to get help, right? And a lot of times that was very helpful when I was in certain classes and I would be taking them with people and we would basically study together. We did our homework together. But then I also remember being like alone in classes and not really knowing anybody that, was kind of on the same level that I kind of felt comfortable in that meeting. And it was very difficult sometimes when you would struggle with math, and at least when I was going through math class, that, we didn't have the internet with all the solutions. I guess we did, but we just didn't really use it in that regard. We didn't have videos, that we were constantly looking up the video library that we do now, where we can just, look up so many different problems and very similar. And it was very difficult to go through math. And also when you struggle, like to not have something to fall back on. And so I thought the Discord server or creating a Discord community would be something that would be beneficial for people. It doesn't matter, really where your strength is in mathematics. If you are just entering, into the algebra, or if you've already kind of bypassed, the calculus curriculum and you're looking for some, just some help as far as in anything. Well, thank you, Alexa. Well, thank you so much for that. I very much appreciate your super chat. Thank you, Mr. McLogan. So that's kind of what, I wanted to see out of the Discord, and it is definitely involved. I've seen being a part of the Discord has been amazing for me to be able to see the amount of people that are helping each other out with their questions. People are posting questions. People are getting their questions answered. People are, it's not just so much like, I need to see this answer, like help me, but, really some people are doing a really good job. One of the things that I did not want the Discord to be is just like something where people get the answers, right? Kind of like a post it like on Reddit. How do you do this? Just, post answers, but no, really something to be able to help people, understand the problems. Well, it really got to me thinking when I'm answering a lot of these questions that I get is, how do I get better at math? How, like I'm struggling with math. Like, how can I get better? How do I take this class and whatever else? And one of the kind of things that kind of struck me is, math, math is about doing, right? You're not going to get better at math watching math videos. You're not going to get better at math showing up to every live stream that I do and looking at all the different math that I do. Yeah, I'm sure that's going to help you out, but it's not going to, you're not going to be able to, go from like an F to an A just because you're watching some math videos, or me explain a certain concept or a problem. But you need to be able to do stuff, and you need to be immersed, and you need to be consistent. And that's one thing that I keep on saying over and over, to my own students as well as on is like, being consistent, working on math, trying to do this every single day. And that's one of the reasons why, if you guys are also following me on Instagram or my stories, I talked about my 30-day challenge, which I'll be talking about that coming up a little bit more, but that's going to be a math challenge where we'll be doing some math problems every day in the month of March. And so that's something that, I wanted to do because I wanted students to understand the power of being consistent with your mathematics, the power of being consistent, of working on math and thinking about math. And in Discord, it kind of works the same thing. I have seen a couple people that all they're doing is asking questions like, get me help, I need help. And I'm like, what? That's not the power of the Discord server. Like, of course, there's amazing people out here that are willing to, help you and explain, the problems, but you're going to get more benefit out of Discord by tutoring. And that's kind of why I came up with the title of this live stream, is because I think for people that are looking to get better, you're going to get better by helping other people with their math. You're going to get better explaining to other people the math that they need help on. And so that's why I was looking in for, tutors that said, hey, if you want to get better at your math, become a tutor. Help other people explain their math. And the best thing about the Discord server is, you don't have to help every single person with their question. Of course, you can't answer everybody with their questions. One of the things that's been, did not expect when I started doing these open live Q&As is the wide variety of math that I would receive every single night. Not just like topics. I knew I was going to get obvious random topics, but from math all around the world that, the way that, a lot of the vocabulary is different. The way that the problems were set up were different. And in some of the stuff, it's, I can make the connections. I'm like, okay, I understand what they're asking or what needs to be done, and I can go over it. And then some of it, I need to kind of sit down and like really kind of understand this a little bit more from what they kind of know and what to kind of teach from this. And I think that that's something that's obviously benefited me looking at different problems, looking at how problems are presented, not just what I'm familiar with, in my school system or in the United States, but seeing how different mathematical curriculum is approaching similar topics. And so I would highly recommend if you are looking into getting some help on Discord, one thing I kept on saying is like, ask a question, help out somebody on a question, right? You don't want to be the person that's always just asking questions. And also, start, helping other people with their questions, even just think about what questions you can answer or even what input you can provide. And I think you start seeing that give and take relationship really starts to elevate your kind of understanding, and then obviously your status inside the Discord. But Discord is a free and open community, and so it's not something I had a couple people reach out to me on email. As far as like, oh, this is like a paid position or anything. I'm like, no, that's not the point of the tutoring or the Discord, for anything. I don't take anything from the Discord. It's a way that I wanted to utilize, people that, come to me immediately for work because they see my videos or they see that I, take questions and answer them. They immediately want to always submit questions in me and get my help. And unfortunately, guys, it's just, I don't even have enough time to answer all the questions on the live stream, nevertheless, the ones that also come in through Discord. So, But yes, absolutely. Asking the questions is, very, very important. Melinda says as well, like it's, I want the serve for people to be able to ask questions, to pose those questions, and to get help. That's the point of the server, is to get help and to help others, with their math, to broaden your understanding with the topics and everything like that. So if you guys have not gone to the Discord, I do have the link here on. One of my invite links. Also, if you wanted a hyperlink, that is in the description down below. So just want to let you guys know about that. Check it out. If it's something that you're interested in, awesome. Might be something that might be useful for you. There will be some things that I will be opening up a little bit on the Discord, at least some ideas that I have coming up further in future. So therefore, a lot of times when I am referencing something on my channel, there'll be some immediate kind of information available in the Discord, or some different channels that I will make up. And I might actually not even think about that. I might actually involve something with my challenge maybe in that channel as well. That's a good idea. Yeah. I didn't even think about that, but yeah. So that's definitely something we'll be doing as well. And then also there is a members channel as well for YouTube members. That is another thing that I kind of opened up as well, as far as my YouTube members, which I am starting another live stream at 10 o'clock. So that means we need to get on. All right. Do you have to be 13 plus? I believe you do. Nice. I'm literally doing my homework right now. Awesome. Okay. All right, guys. So let's go ahead and have algebra final this week. Well, good luck, Andor and Faith. Algebra 2 and trig. You guys got it. All right. So I do actually have some trig that definitely we're going to be doing in this. So just a reminder, guys, if you just kind of joined on, these are going to be questions that were pre-submitted. I do have a Google link as well as the Discord link that are in the description. So if you do have questions coming up in the next couple weeks that you would like for me to answer, then please feel free to use those links, submit your questions, and I will be more than happy to address those. Actually, before I get to this though, I did want to let you guys know where you guys were. Now, I didn't know if you guys were just being so nice to me. Did I actually do that one? No, okay. I didn't know if you guys were being so nice to me on my survey that I did, but this is the question that I posed yesterday on my community post, and yeah, online videos was the number one choice, 63%. For the first couple of hours, it was like the tutor and online videos were pretty pace and pace. We're pretty neck and neck with each other, but then it looked like online videos. And so I obviously, I appreciate it. I would actually say that was kind of surprising for me, just because I was thinking with so many students learning online, going virtual and everything like that, I was actually surprised that students, thought online videos was like their number one place to go. I mean, I guess maybe it is a little bit more prevalent now. But I would definitely, for me working as when I was learning math, I would definitely say having a tutor. I used to go to the tutor lab every single day when I was getting help. Just even if I didn't need help, I'd just go to the tutor lab and do my math just in case I ever had a question. And then also one thing I forgot to mention, really my understanding of mathematics really grew once I became a tutor. Once I started helping other students with their math, and this is when I was in college, when I was in my undergrad, I used to work at the tutor lab, and then I became a tutor at that I used to go to the tutor lab, as I mentioned, every single day. And then once I got into my upper level mathematics, curriculum, then I just became a tutor, and I went back to that exact same tutor lab almost twice a week, almost every single day. But I was there a lot, helping students with their math. And I can definitely say that by doing that, that definitely helped me out. With my understanding of the curriculum. I remember tutoring students in a class that I previously took. And even though I understood it originally, I remember getting I think an A in that class. But then going back through the problem, I didn't really know what I was doing. I just knew what I was doing to get the question right. And there's a big difference between knowing what you need to do to get the question right and then to actually knowing it to understand it. And that's what kind of tutoring allowed me to be able to do was, when you need to explain it to somebody, when you need to go through that kind of thought process, it really brings together like your thought process, and you're putting the problem together, to help them and to explain to them. And yeah, I understood things a lot better. And I would definitely say that was one thing that, definitely helped me, even continue on like through the rest of my degree as I was finishing up. Even though the math I was taking was like way above this, I could start making more and more of those connections that I found. All right. Well, thank you, Luca. All right. So let's go ahead and get on with this. Let's go and change our colors to red. And then I do have one little stop where I believe at like question number 5, we'll go and take a break. And if you guys do have any questions inside of me and there, then feel free to add them up. All right. So the first one is, I believe by Ravel, was asking, he had a question, and then also was asking about A, B, B, C. And Ravel, I would just say, should you take AB, AP Calculus AB, or AP Calculus BC? I think it just depends on what you want to do, where you want to go. Taking it in 9th grade is early. So, if you're taking pre-calculus in 9th grade, so, you have time. I think it just kind of depends on what degree you want to go into and what other courses you can take. If you're going to have a gap, or if you're going to be able to do some dual enrollment, taking some college courses. If you are going into more of a mathematical field, then I would look into taking BC and, continuing on. If you're not really sure what you want to do, then, I don't think there's a rush that you have to go and take the ABB, take the BC. Maybe if your school allows it, take AB, and then, maybe go into statistics and then maybe come back to BC, or look for some different dual credit and some different courses. Those are some options and opportunities for it. I think it just kind of depends on where you want to go with it. You can be good at math and you can like math, but is that what you really want to get a degree in? Not so much math, but like, computer science is like, how in depth do you want to, go with your mathematics? And I think that should be really your main driving force. Well, Abigail, now we're adding on to this topic. So what grade should you give in pre-calculus order BC? It really kind of depends. I think it depends on the rigor of your pre-calculus course, obviously. But I think if anything, if you feel like you're strong with the content in pre-calculus, then and you want to get that and you want the pace and the rigor of BC, then go for it. Obviously, I think if you're getting anywhere from a C below, like there's going to be some gaps, there's going to be some issues, but I remember, I don't think that's the case for everybody. Of course, I think, obviously people know why they got a C in a particular course. It could have been just one bad test grade, right? Or it could be like you didn't understand anything and you barely got by with a C. Well, then BC is going to be pretty tough, for you to do well in. And so, there's just a lot of variables in that case. I really think it is like, one, you're just going to want to go with your content and kind of have a good understanding, from your pre-calculus teacher as far as that rigor and preparation for the, for calculus, for AB or BC. And then really, in my opinion, I think anybody, most students that are in pre-calculus that are going into Calc AB anyways, like a lot of them are going to, if they put in the work and the effort and the time, they can do the BC. It kind of depends on like, what is it you want? Why do you want to go to BC compared to AB? Right. And I think a lot of times that's the question I'm asking students, they when they're making that kind of decision, what is the purpose of going to taking that level? Because a lot of times, even when they go to the, even for the, a lot of times they just want to get exposed to it, and that's fine. Like, go for it. And a lot of times students are like, I really need to learn this stuff, and like, well, BC is going to be pretty quick, so like maybe you need to just go and slow down. So therefore, it doesn't matter even if you get the credit, like you're going to have to retake the course anyways when you get to college. Right. So just some things to kind of think about, but I definitely talk to your pre-calculus teacher and the calculus teacher and kind of see what's going to be the best fit. And then also based on your own personal situation. Okay. That was a very long-winded question. But thank you, Abigail, for adding that on. So therefore, hopefully that answers some of your guys' questions, because I do get that quite a bit. Talking to me about ABBC, which you guys should go into. Because this year I do teach pre-calc. I've been teaching pre-calc for a long time, and I've taught AB, but never taught BC. And And but I do see a lot of my students, making that transition, and I can kind of see, when students are successful, because obviously I have a good relationship with our calculus teacher, when seeing which students are successful and which ones are not, depending on what they chose. All right. So next question, or at least this math question, is going to be sketch the graph of the function, include two fill periods, use the graphing utility to verify your result. Okay, so to graph this, we need to understand what cosine looks like. Okay, so remember guys, the cosine graph looks like this. Right? So that is going to be cosine of x. Or actually, this is what y equals cosine of x is. Okay? Now, if I wanted to graph this at y equals 2 cosine of x, right? So I want you guys to understand something. This graph has a amplitude. If this graph right here, so this would be from 1 to -1. So if I was going to graph y equals 2 cosine of 2x plus 2, well, what's going to happen is that graph is going to go up to 2, down to 2, and then it's going to be shifted up to 4, right? So that's very, very important. Now, the graph is not being shifted left to right at all, and this is the main key determination, because I want you guys to see the asymptotes for secant, right, are going to just be the inverted portion here of this cosine graph. Well, so first of all, I know this y-intercept is going to be at 0, 4. And if you notice, there's only one graph that has a y-intercept at 0, 4, right? Which is right here. So I can say that this is going to be your answer, right? Because again, the graph is being stretched from -2 to 2. That would be the amplitude of cosine. And then it's being shifted up 2. And since the cosine graph and the secant graph are going to share that value, this like vertex here, then you could see there to be a x-intercept at 0, 4. All right, find the exact value of cosine of 120 degrees. So again, another trick question. Obviously, I could answer that really quickly with just using the unit circle, but I kind of want to address this in a little bit different manner. We'll kind of go through the unit circle, but I want you to kind of see something like, first of all, if we're going to graph 120 degrees, I want you to think about that in standard form. So standard form starts at the positive version of the x-axis and goes to here, right? Now, so there's going to be that. If this is 120 degrees, then we know this angle right here is going to be 60 degrees, right? And that's going to be what we call our reference angle. Now, the cool thing about knowing this, our reference angle, is we recognize this to be a 60 degrees. Well, thank you so much, Anne. And you split your videos. Well, I am very happy to be able to help you out. Cheers. So therefore, that's going to be 60 degrees. And if you know anything about special right triangles, you know that is going to be 30 degrees. Now, what are the sides of a special right triangle? Well, 30, 60, 90 triangle. So the cool thing about 30, 60, 90 triangle is we actually just did this in my, this is actually a horrible 30, 60, 90 triangle, actually. Because that, should actually look like this, right? Yes. There you go. So that's going to be 60 degrees, and then that would be 30, right? So the cool thing about 30, 60, 90 triangle, if you remember, we're actually teaching this in my geometry class right now. All right, so that is 60 degrees, 30. So if you remember, we have the short leg and we have the long leg. So this is our short leg. If that's x, then the hypotenuse is 2x, and then this is x going to be square root of 3. Right? Now, again, the cosine of 60 degrees, remember, is adjacent, right? The adjacent side over the hypotenuse. Now, using this relationship, what we do is a lot of times when people explain this, they'll say, oh, well, what about if it's on the unit circle? Okay, so now the unit circle is a circle or a set of triangle, or basically it's a circle with a set of points that we can create these triangles where the hypotenuse is 1. So understanding this relationship, you can see from the short leg to the hypotenuse, it's double the length. So if I give you the hypotenuse, if I say, hey, let's talk about this on the unit circle, that means the distance from the origin to that point is 1. So to go from short leg to hypotenuse is multiplied by 2. To go from a hypotenuse to short leg would be divide by 2, right? And then this would be multiplied by the square root of 3. So on the unit circle, that's where this point comes from. And a lot of people don't understand the points on the unit circle. They just have like kind of them memorized. But they really just come from special right triangles when the hypotenuse is 1, right? Instead of any relationship, it's just when the hypotenuse is 1. So when I want to find the exact value of cosine of 120 degrees, no, I don't expect you, nor should we expect you to try to redraw a triangle every time. We kind of summarize this with it being the x coordinate. But I want you to understand here, I was talking about a triangle here in space, right? But when we talk about a triangle now here on this unit circle, you can see that that's going to be a -1/2. So the cosine of 100 degrees is going to be a -1/2. Did anybody call me out on it yet? No. Well, thank you, Elijah. Happy to help you out for that. Just make sure. Okay. Please. All right. See then. Hold on a second. I think there we go. Okay. I think I got, hold on a second. I just want to check something. Okay, cool. All right. So now let's go and get into the next one. So hopefully that was helpful for you. The next question. Is there a specific problem you would like for me to explain? Oh, no, I'm sorry, I'm reading my things. Yeah, the student was saying factoring by grouping. So when factoring by grouping, basically all we're simply looking into doing is, taking let's just kind of look at this first problem. They sent me 3, and I'm not going to be able to do all 3 of them. So let's just look at this first problem. AY minus 3BX plus 3BY. Okay, so when we're doing this, basically, you can see that all of these problems don't have something individually in common, right? So what we can do in this case, sorry, I'm just trying to watch the chat and keep you guys underground here a little bit. So if you guys look at these, they don't have anything in common. However, if you can see, like, if I group the first 2 terms and the last 2 terms, they have, like, these 2 terms have a 5 and an A in common, and then these 2 have a 3 and a B in common. So what I'm going to do is I need to rewrite this, and I'm going to group those first 2 terms. So I'm going to rewrite it like this. So 5AX minus a 5AY. So I'm going to group that using grouping parentheses. And then I don't want to group that with the negative. What I'm going to have to do is write a positive, and then rewrite this as a -3BX plus 3BY. Okay, so I want you guys to kind of see what I did here is I didn't group it from the negative because I didn't want to create like distributive property. What I wanted to do is you want to make sure you break it up because, again, like, isn't adding a negative the same thing as subtracting, right? Okay, so now you're just going to factor out your GCF. So what do these have in common? Well, these have a 5A in common, right? So when you factor out a 5A, you're left with an X minus Y. And then over here, you can see we can factor out a 3B. But again, you want them to be the same expression here. So I'm going to factor out a -3B. So by factoring out a -3B, so it's going to be plus a -3B, that's going to leave you with a X minus Y. Now what I want you to see is now these 2 expressions, right? Because these expressions are separated by this addition problem, they have an X minus Y in common. So I can factor out an X minus Y. And that's going to leave me with what's left over, this 5A and this -3B. So that's going to be 5A minus 3B. Now, really, it's plus a -3B, right? But again, just like we talked about here, plus a negative is the same thing as subtraction. So you can see that's how you would factor by grouping. Well, thank you, Days. I'm that. You are very welcome. Wow, bubbly. Jeez. Ouch. Okay. Let's get to question number 4. So number 4, William, I saw your work. Your work looked good. So I'm not sure if you want tips and tricks. I guess I would say when you're doing a logarithmic equation, there's a couple things you're going to want to do. Is one, if you want some tips and tricks, I love tips and tricks. Make another video on this. One is use the properties, right? So what I saw from you was the use of the properties. That's good. Use the properties, use the quotient properties, use the difference properties. What you want to do is condense the logarithms. And then step number 2 is either look to when you isolate a logarithmic equation. So, look to isolate, and therefore you can solve by rewriting as an exponential or using the rules of logarithms. Or you're going to want to use the one-to-one property. And I think that's what you did in this case. So if here you can see we can use the product rule. So I can say log of 2x minus 7 times x minus 1 is equal to the log of x plus 1 times x minus 3. And now when you have a logarithm equal to a logarithm, you can go ahead and divide them out, basically eliminate them out, and then you can multiply these to create a quadratic equation. And so therefore I'd have a 2x squared, let's see, minus 2x minus 7x plus 7. And then over here, you're going to get a x squared minus 3x plus x minus 3. Okay, and now once I notice this is a quadratic, I'm just going to get everything to the same side. Right, so let's subtract the x squared. Let's add a 3x. Let's add a 3x. Let's subtract an x. I'm just going to do this to like everything. And then let's add a 3. All right, so let's see what I get here. I get an x squared. Let's see, that's going to become an x. And then that's going to become a minus 8x. So that'd be minus 7x. And then plus 10 equals 0, right? And again, if you're going to solve a quadratic, you're going to want to set that quadratic equal to 0. And Days, I saw your thing. Go ahead and check out the check out my live stream last week when I talked about that. But no, the short answer, not many, but I have, and I do a little. All right, so now we just want to see what two numbers multiply to give us a negative 10, right? Add to give us a negative 7. So that's going to be x minus 5 times an x minus 2 equals 0. So x equals 5 and x is equal to 2. And there you go. Those are going to be your equations. So user properties, condense, and then go ahead and either isolate by converting to an exponential or using the one-to-one property. All right. So there we go, ladies and gentlemen. Take a quick little break here for my open. If you guys do have any other questions that maybe I didn't get to, I know there's some ones that were asking before there, but if you do have any like specific questions or anything you guys want me to talk about, I'll take a quick little break from the preset questions, and I just kind of left a little openness here for you guys. Do you play video? Math is so difficult. I'm struggling. I much hate it. Yeah, I can definitely understand, Ben, for real. Basically, you've been saving since 8th grade. Oh, and after I know I expressed my gratitude. Well, you are very welcome. That is all the gratitude that I need. I'm very, very happy to be able to help you out. Just keep on working hard. That's the best that you can do. I know it's I know it can feel like a lot of weight, struggling with mathematics and moving, but I think you're doing the right thing. Keep on moving forward. Just keep on taking those steps and getting help. Alexa, derivative trig functions. Thank you for your question. I'm not going to be able to get with them. I don't have any other specific questions for them there, but yeah, I think I have one derivative question that I'm answering. It's a very, very basic question that we'll come into, but I don't remember the trig derivatives right off the top of my head since I haven't been teaching the calculus, so I won't be able to do those. I know every single time difference of differentiation and integration. Everybody wants to get into more calculus questions from there. But yeah, for the sake of my explanations and everything else, I will hold off a little bit more on the calculus stuff. Just for the sake of when things aren't like fresh in like my teaching. I mean, it's like sometimes it becomes difficult to get the explanation the way I want to say it. So a lot of times I've found out, especially during these live streams, doing so many of these, that you don't have to answer every single question, or don't attempt to answer every question, because if you're trying to address everything and you're not on point with it, it's not really going to benefit as much for you. So one of the times that I've had trouble, or at least since I'm not teaching the calculus, for that, it's just not as fresh, and I just don't feel like my explanations are like as on point as I like want them to be. More than one transformation. Sure, complement, but the fact. No, is it hex integration and finding the antiderivative? Yes, I mean that's a very simple, very simple explanation. Thank you, Melinda, for that. But yeah, that's basically. I mean, if you're looking at differentiation, you're looking for that the antiderivative. I wish I had your function teacher. That's good. What's your favorite math class to teach? Well, Abby, my favorite math class, let me go and get into functions. I'm not really sure more than one transformations. Sure, fine. Well, calculate the slope of that is going to be 2 because that is going to be the coefficient of your x. I wanted to look at, somebody actually was answering some questions earlier before, but my favorite class to teach used to actually be this was actually really cool. This is actually back in the day. So to give you an easy answer, I really do like calculus. I actually really enjoyed teaching calculus, and I wish I could go back and teach it again. Unfortunately, that's just not how the schedules have kind of worked. So I didn't get that chance this year to go and do that, but I really did actually enjoy teaching calculus because I think that was really where I was able to expand upon teaching the pre-calculus and really kind of get to see those connections and help students with those connections. So actually, I'd probably say calculus was my favorite class to definitely teach. Besides that would be no, it's not. Let me go back. Besides that would be another one would be the pre-calculus. I really enjoyed obviously teaching pre-calculus, but my favorite class that I had it was called Math Topics, and it was really cool. It was the first year that it came out. They basically had no curriculum for me. And so I basically just got to teach whatever I wanted to. They're like, hey, here's the book. And you just create whatever you wanted to. And that was my absolute favorite because I was able to, it was kind of like a discrete mathematics, course. We just there's different topics and different, topics. And I really just kind of pick and chose whatever I wanted to teach. And I could there you go, Daniela. I knew there was a question for you. So yes, I will get to you, Daniela, for that. Thank you. But yeah, it was so cool. I remember that brought me more joy than anything else, just because I got to, I wasn't worried about student testing, or in grading and all that kind of stuff. I just got to enjoy and actually have students enjoy the mathematics. There was no pressure as far as the tests and grades and end of the year and stuff like that. So it was a really, really fun course. And then I only taught it for that 1 year. And then they gave me something else to teach. I can't remember. And then the course just got stripped down and they turned it into you have to teach this and this and this. And I think now it's I taught it a couple years later and out of a different book. And it was horrible. It was boring. It was then it turned into a math for college readiness course. And it was just, then kids hated it because then we're just forcing them to regurgitate, old math stuff that they never learned, never remembered and stuff like that. It was horrible. You can ask your own questions, but I only did one open live stream, but I will see how much time I have left. I do have another live stream at 10 o'clock for my YouTube members. So I do got to make sure I get to my questions before that, but you can always go ahead and submit your questions each and every week here on my Google form that is in the description. All right, but I did mention to Daniela that I will get to her question because she was here before the live stream, so I want to make sure I can honor that as best I can. So f of x equals 5. And before the square root, on the top of the square root, f of x equals 5 before the square root on the top, and the square root of x over 9 over 5. Over 5. Okay, well, I'm not sure, Daniela. You might have to redo this to me. Go ahead. I'm seeing the x plus 9 over 5. So is it the fifth root? Oh, it must be the fifth root. Okay, that's what you're saying. So the fifth root of x plus 9 over 5. Okay, and then g of x. And maybe just give me a thumbs up if I'm getting this correct. G of x equals 5x to the fifth minus 9. Okay, so it doesn't really matter what we have here. Obviously, we can probably simplify this a little bit further and kind of see what's going on. Yeah, we can. But basically, the main idea, you need to understand, if I have f of g of x, and I'm just going to do 1. I guess I'll do the other one. It's fine. If I have f of g of x, right? All that it means is f of g of x. Okay, so and again, guys, I'm not going to be able to get to any other additional questions here. I got other ones that are pre-submitted that we're going to have to get to. But again, feel free, guys, to always add in your questions. And every week I try to do like a couple open questions, but I'll just going to address this one and then we'll get to the rest of the pre-submitted. So I have f of g of x, that is f of g of x. So like for instance, if I had like f of 1, right? What are you going to do with the 1? Well, you're going to plug the 1 into the x, right? So if I say f of g of x, well, then you're going to plug in g of x, right? In for the x. Well, in this case, we actually know what g of x is. That's 5x plus 5x to the 5th minus 9. So when I say f of g of x, all we're simply going to do is we're going to plug in, instead of plugging in g of x, right, we're going to plug in what g of x is, which is 5x to the 5th minus 9, and then plus 9. Right? And that's all over 5. Okay? Now we can go and simplify under the radical. And when we go ahead and do that, that's going to give us a 5th root of 5x to the 5th over 5, right? Because negative 9 plus 9, that just goes to 0. You can take the 5th root of x to the 5th, which is just going to be a x. You cannot take the 5th root of 5. So it looks like we're going to have the 5th root of 5. And that will be all divided by 5. Then let's go ahead and do the g of f of x. What am I doing? Why am I writing it like that? So g of f of x is basically just going to be the other way around. Now we're going to plug f of x into g of x. So that's going to look something like this. 5 times the 5th root of x plus 9, divided by 5. The whole thing is going to be raised to the 5th minus 9. Okay, so the 5th root of 5th root raised to the 5th power is just going to undo each other. However, we can also take the 5th root of 5, which I do not know. So let's see, in the numerator here, I'm going to have an x plus 9 divided by x to the 5th, and then minus 9. And then obviously we could go ahead and do a little bit more math to go ahead and combine these to each other. And, you know, get them to be like get the same denominator, x over 5, but I'll just keep that short. So hopefully that helped you at least understand the concept of composition of two functions. And you're very welcome, Jaden. Congratulations on passing pre-calc. Yes, like that. I don't know how to word that part. Yes, I know. It always is kind of confusing with I remember my pre-calc teacher would call it like golf and fog. That was just the way we would kind of remember that. But yes, hopefully you understand this kind of idea of when you have a value, right? And again, all we're doing is we're doing the same thing now with functions. Bye-bye, Rihanna. The x-axis. Yeah, you just do the same thing. Help it. I'm not sure. You just swap the x and y and solve for y, or reflect about the y equals x line. All right, question number 6 says, from Liam, is finding the domain and range of a piecewise quadratic absolute value function. So the cool thing is piecewise, right? We have 2 or more functions. Now, the nice thing that Liam asked was like a quadratic or absolute value. Well, here's the cool thing. A quadratic is defined for all real numbers, domain, and the absolute value is defined for all real numbers in the domain, right? So the only way that our piecewise function is going to change is going to be the restrictions, right? So let's just call this, let's just do a problem. If I had f of x is equal to, let's say like x squared minus, or let's say x squared plus 1, right? And we say x is going to be greater than 0. And then I can say absolute value of x, minus 1, where x is less than or equal to 0. Okay, so the cool thing is unless the domain is like separated, or we can see by these values, like if it's not included for one of the values, then the domain is going to be all real numbers because our quadratic and our absolute value are continuous functions. So the domain is going to be continuous for all real values as long as the restrictions are not going to change that. Now the range is a different story because you can see these graphs are bounded below, right? They only go as below as y equals 0. So we do need to look at the restrictions. We need to look at the graph as being reflected about the x-axis or the vertical shift. Now this graph, they're neither of these graphs are being reflected about the y-axis, but you can see this graph is going down 1. So that means the lowest point this graph is going to go is from -1. So the domain here would be all real numbers, and the range would be from -1 to infinity, right? And if you want me to show you what this graph would look like, I guess I'll just do it over here. So this would be +1, that's an open circle. And then -1, and that's less than or equal to. So it'd be like that. So it's like a combination of the V graph and the U-shaped graph. Again, remember when it's greater than, it's an open circle. When it's equal to or less than or equal to, you can see that's going to be the closed circle. Wu-Tang, you're talking about teaching. I've been teaching since 2007. I've been making YouTube videos since 2010. And I've been going live weekly for 54 weeks. So hopefully that answers one of what you're looking for. All right, so question number 7 says, kind of explain like this understanding of the input-output value. And that's kind of like what we were talking about, Danielle, with what we're looking over here, like this composition of functions. Like, so suppose I have a function f. Okay, cool. What is the input value of x? Well, you got to understand something. Like when you have a function, we have f of x, right? So f is what we call the name. X is what we call the input value. So that's what we're going to plug in, right? You plug into the function. Now, again, remember it's a function. You get something in, you get something out, right? So when we get something out here, we call that like this rule. What it equals, typically is going to be, come on, I can't write worth crap, is the rule or the equation. Now, when you plug something in, that's also, when you get a value or even just an expression, that's going to be your output. Okay, so you can think of it as your rule, the equation, or the output. So what is the input value when I write f of 3 equals 7? Well, that's going to be 3, right? The input is your x. What is the output? Well, that's going to be what it's equal to, which is 7. What is the ordered pair? Well, when you're writing an ordered pair, x represents your input, y represents your output. So that'd be 3, 7. And I have a function named f and I. Describe it algebraically by writing. Not sure what those questions are meaning. But if I wanted to be able to do this, like, yeah, if I plug in f of 0, like, what does that mean? Well, that means, see, right now the function, Frank, right, has that's f is in terms of x. So x is what we're going to be my input variable. So if I'm going to change my input variable to be 0, then I'm just going to replace wherever I see an x with 0. Right? And that's the same thing I did over here. Like if I want to change my input to be g of x, then wherever there was an x, I'm going to put a g of x. And that's exactly what we did up there. So if I want to find f of 2, then I say, all right, well, let's make the x2. And I want to do a f of -5, then I'm going to replace the x with a -5. Okay, so therefore, let's see, that's 4. I don't like when that does that. That's going to be 10. That's a -15 plus 4. That's going to be a -11. Voila. You're very welcome. Is there a concept processor you were having trouble? Yes, I need function notation. I really have time struggles. How can I do that? Well, I think I helped you out. See above. I think I maybe added that one, even though that doesn't really help. I'm not really sure what the student needs help with, but hopefully I think just explaining this last problem helps out. Is there a concept or a process you're having trouble with? You can explain. Oh, I just did that. So now I'm starting to get tired. Okay. Ibrahim is asking for, I think he was asking for graphing this. So I've never seen this otherwise. That was kind of an interesting thing, but I'm assuming this is going to be for all values. Since this is only between -1 and 1. Then this is going to be for all of the values. So let's go and see what the graph is. So again, when you're graphing a piecewise function, you basically have y minus absolute value of t, right? Okay, so best way to graph that would be to absolute value t. Oops, I'm sorry. To rearrange it, so it's a negative absolute value of t plus 1. Okay, so if we know the V-shaped graph, right, is opening up, right? I showed you what absolute value graph looks like. So this would be like y is equal to absolute value of t. So now, if this graph is being reflected about the y-axis, that means it's going to open down and then go up. So, and it's going up 1, so there we go. and then it's going to go in the down direction. However, it's only true, like, since there's no stretch and compression, you can see it's only between -1 and 1. So that's going to be from here and here. So it's going to be like a little triangle there. And then it says it's 0 equals everywhere else. Otherwise, I don't. Okay, so I mean, I guess it's just going to look like that at 0. It's just kind of very weird graph from there. So not really sure. I'm not really used to that, and I've seen that before. So hopefully that was at least helpful. I can help you with that one. The 0, you typically would say like for all our values, but you can see it's already less than or equal to, and for 1 and -1, which was just kind of weird. I would expect if it was going to be equal to 0, then we just maybe use the less than instead of the less than or equal to. But all right, Joselle was asking as far as how to use that reference angle. So let's go ahead and let's do like number 4 and 5, because that's going to kind of go back to what I talked about up here as far as the triangles. When you're doing the reference angle, you're finding the angle between the terminal side and the x-axis. And what that's going to do is that's going to allow you to create a triangle. Now, we're actually not going to draw the triangle again, because that kind of takes a little time. But hopefully, if you were around for that previous explanation, you can hopefully kind of see some things that make sense. Now, in this first part, we have the cosecant of -300. All right, so we're going to go in the negative direction from our standard form. And we know all the way around circle is 360. So if I'm going to go 300, right, again, we can recognize here, if this is going to be our theta, then this would be our reference angle, which is theta prime, which is going to be the distance away from our x-axis, which the reference angle is always acute and positive. So that's going to be 60 degrees. Now, again, you could create your special right triangle if you wanted to, but hopefully if you have a understanding of the unit circle, we can recognize this coordinate point to be a positive 1/2 square root of 3/2. And again, the cosecant is going to be, remember, hypotenuse over opposite, or on the unit circle, it's going to be 1/y, right? So cosecant is 1/y, right? So the y coordinate's right here. So I can say that's going to equal to a 1 over a square root of 3/2, which you can multiply by the reciprocal, and then rationalize the denominator to radical 3/3. And then another negative. Why am I picking two negatives anymore? So then we have the other one is the secant of 3/4, negative 3/4. Okay. So again, same thing. Let's go ahead and graph it. So negative is going to be in this direction, right? We know all the way around circle is -4/4. So this one is going to be pi/4 away. So that's going to be your reference angle, which is be pi/4. So we'll call that theta prime. All right. So theta prime equals pi/4. That's how far it is away from the x-axis. If we're looking at the point on the unit circle here, that's going to be a negative square root of 2/2, comma, square root of 2/2. So secant is going to be 1 over x, which is equal to 1 over negative square root of 2/2. You can multiply and rationalize the denominators, or you can multiply by the reciprocal. And then, I don't know why I'm doing all this work, but then you can rationalize the denominator. And when you go ahead and do that, you get a negative square root of 2. Don't forget there was that negative there. I just kind of stopped writing it for some reason. I'm not sure, Garima, which part you were referring to that you want me to explain again. Oh, come on. There we go. Perfect. But, so yeah, that's a negative, and then you just multiply on the top and bottom. All right, question number 11 is how many ways can the letters share be arranged? So I can't remember who has asked the question, but they wanted me to explain things. And it's been a while since I've been doing combinations, permutations, but I typically kind of like my calculus. I'm like, I just don't really want to go through my explanations as well, but I just figured I'd kind of go through at least with this one, and I'm hoping I got the right answer. So if you want to be able to arrange this, you got to think of how many combinations you have, right? Because if you actually not share, you're still going to have that 5 range. So the way that this is going to work is if you can think here, how many operations you have were the first term. Well, you have 5 letters, right? Share, S-H-A-R-E. So you have 5 options. However, into the next one, you already have a letter here. So you only have 4 available letters left over, right? Because if you have a letter here, right, then you're only going to have 4 more here. And then after you pick a letter here and you pick a letter here, then you're only going to have a variation of 3 of these letters to the next one, and then 2, and then 1, which I'm assuming and I'm hoping when you multiply that out, which is the factorial of 5, you get a 120. So hopefully it kind of makes sense because, again, you can only have that S once. So that's why we go down to 5, 4, 3, 2, 1. Wow. Jeez. That's not good. All right. So is there a specific problem you'd like for me to explain? What is the derivative of ln of x? I was like, oh yeah, okay, I remember ln of x. So let me go and do this. Now, there is an important thing here. You got to understand we do have a function inside of this ln of x, right? So if we're going to do the d over dx here of ln of x squared plus 3, then that is just going to equal here the 1 over x squared plus 3. Right, which is going to be 1 over x, which is the derivative of ln of x. But then you need to multiply by the derivative of x squared plus 3, which is going to be a 2x. So we'll have a 2x over a x squared plus 3. And voila. Hopefully just remember the derivative of, oh my God, why is this happening? I guess I should have done that. All right, cool. So we have the 2x divided by x squared plus 3. And then last but not least here, guys, is, oh, good, perfect. The last one, because I do got to go. I do apologize. So for this one is asking for, find the amount. I think the student was asking, is this compound or is this simple interest? So kind of quick way to understand that is when you try to find the amount of after 5 years invested at 8%, interest compounded semi-annually. So the thing is since it's compounded, right, this is going to be compound interest. When you're looking for simple interest, that's just going to be the basic interest, over a set period of time. But when you have something compounded and you actually have times that it's going to be compounded, then you'd want to use the compound interest formula. So if you just want to find the interest on amount of money over a number of years, then you use simple interest. But if you want to see the interest on something that's being compounded here, then that is when you'd use your compound. So you can see that this is being compounded, so therefore you'll use that. So, all right, ladies and gentlemen, that is it for this live stream tonight. If you have more questions, please feel free to go ahead and submit them on my in the Google form that is down below. Or also, if you have not checked out the Discord, then go ahead and head over there now, get some questions answered, help some other students out. That is what it is there for. However, for any of you guys that are on the YouTube members, I will be going over to that stream now. I hope to see you guys there, and I wish you guys a great week. I will see you guys next week. Cheers. Hmm.